Okay, everybody. Shay Live 1 Video Solutions. I gave you the worked out the answer key yesterday. I can't tell you what these things will be for points. My guess is it'll be 12 points for the first test and 8 for the second test. So 12 points for the first. That's a complete another guess. Just assume you're talking 1 or 2 points for all these problems. All right. So the first one I ask for, f prime of pi. You take the derivative first. It's a good idea to show your derivative, even though you didn't ask you for that explicitly. And then evaluating the pi, and just be careful on your situation here. Plug in your calculator if you have to, if you can't remember. But this comes out to 0, which means the whole thing's 0. That's -1. Be careful of this. E to the 0 is 1. It's not 0. This becomes 1 times -1, or -1. Number 2. Moving on. We have k of x equals the composition h of f of x. They're asking us for the derivative. We need to use the chain rule. And in this case, I asked you for both k prime and k prime of x and k prime of pi. So that's this one up here. I did not ask for that. I only asked for one. So here, the first thing we have to do is we have to find the derivative of k of x. We use the chain rule, which is derivative of the outside, simply h prime, normal inside f of x, times derivative of inside f prime of x. That is an answer. You're done at that point for that problem. All right, the second part of the problem is pi. I evaluated at pi. You can evaluate it at pi and then plug in automatically, or you can plug in pi and then work this stuff out and then plug in the values. It's up to you, but be careful not to make a simple mistake here. This is h prime of f of pi, so the first thing we want to do is solve for f of pi. I did this on the side here. I don't want to do it cluttered up here. And f of pi is the original function. So this is going to be something where we go back and we're going to refer to previous answers. F of pi, again we have e to the 0, becomes 1 plus 1, or 2. So this 2 goes in here. So that 2 right there is put in here. And then we do h prime of 2, which is the slope of the graph at 2. So here's our graph. So h prime is the graph, is the slope of that line, which we can, with our xy coordinate points, find that out to be -2. And f prime of pi, we've already solved that in the previous problem. That will be a frequent occurrence where we're going back and finding the work we've already done, and that's why it's really important that this is clear and concise, where we can go back and find it quickly. But anyway, f prime of pi is -1. That's there. -2 times -1 is +2. Done. All right. The third problem. Let's go there. Okay. And this is what I expect. I expect it to be, without question, you're going to be challenged on your derivative skills, whether it's chain, product, power, quotient, properties, like all these different things. But at the very least, you're going to have a couple of those. So in this case, we've done product, we've done trig, we've done chain, so now I'm doing quotient. And this also includes the chain and trig. But so anyway, derivative of the first, we have to use the chain rule here. So this is derivative of the outside f prime, normal inside 2x, times the derivative of the inside, which is 2, times normal second. This is my denominator. So this is the derivative of the first. This is normal second. Minus the derivative of the second. So the derivative of minus sine is minus cosine. I need to be real careful here. This is going to be a plus eventually. Times f of 2x. So there's my numerator, and here's my denominator, minus sine squared, or the second squared. Then I plug it in. Remember, I'm evaluating at pi halves. So I plug it in at pi halves. Now here I showed you this step, but really you should probably go right through it. So 2x times pi halves, or 2 times pi halves, becomes simply pi. And sine of pi halves, and cosine of pi halves, and 2 times pi halves again. So I'm evaluating all of these x values at pi halves, right? F prime of pi, we already figured out. Again, that's our previous answer way up here. That's negative 1. Negative sine of pi. Well, sine of pi we know to be 1, so this becomes negative 1 as well. Cosine of pi we know to be 0. This whole thing is 0, therefore. And then sine of pi we already determined to be 1. This is negative 1 quantity squared, so positive 1. So then I move this stuff down here. And again, you don't necessarily have to do it this way. I'm just doing it for your purposes. So we have our 2 here, don't forget that, times negative 1 times negative 1, minus this whole 0, all over negative 1 squared. So this becomes 2 over 1, or 2. Make sure you label it at the end. You don't. It's not points off, but like I said, these are human beings who are correcting these things. All right, part D. Okay, so part D gave us an integral function from negative 4 to x of h of t. So this is the graph we're talking about, and it asks us for g of negative 1. And what that means is, let me get a smaller pencil. What that means is we replace x, so g of x is equal to this. G of negative 1, we are replacing that with negative 1. Which means I'm calculating the area under this curve, this is my redrawing of the curve, from negative 4 to negative 1. And remember, this area, I can solve it the same way with either a trapezoid, or I can break it into a triangle and a rectangle, completely up to you. But this comes out to positive 7.5, but because it's below the x-axis, that's negative 7.5. So that's the first step. Boom. Second one is g prime of negative 1. This is the fundamental theorem of calculus, which is the derivative of the integral is just what's inside the integral. So in this case, when I take the derivative of g of x, I evaluate this function at x. So g prime of negative 1 is h of negative 1. H of negative 1 is the y value at negative 1. Therefore, negative 2. So g prime, the derivative of this integral, is the y value of the graph we're integrating. Okay, let me say that one last time. G of x is the accumulation, is the area under the curve, from this case from negative 4 wherever, right, to a value of x. If I take the derivative of this, I'm actually just getting this function here. Therefore, I'm really just getting the y values. So the first derivative is equal to h of, in this case, negative 1. And lastly, the second derivative is going to be equal to h prime, which is the slope of this curve. But at this point right here, this has a sharp corner. Therefore, it is not differentiable at negative 1. Therefore, it does not exist. Morning, buddy. Okay. And this is last one. All right. So, in this one, they give us another integral. We're still dealing with the same graph. All right. This is a horrible depiction of that graph. But anyway, we're starting at x, and we're going to 3, and the question is the values of x that make this integral 0. So we have to think back a little bit, like, okay, wait a minute, what are our properties of integrals? And the first thing we need to recall is from 3 to 3, or a to a, any integral is 0. So that's our first solution, okay? So from 3 to 3 is 0, good. Then we look at our graph, and we realize if we're going from x to 3, so we're starting at x. And because it's 0, it really doesn't matter if I'm going from 3 to x or x to 3, but either way. And I get down to 3, I'm really looking for where the top of my area of the curve is equal to the bottom. So what I'm looking for in this case is this area here, from here to here, is equal to, again, my drawing is horrific, to there to there. So what that means is, whatever this x value is, to that x value of 3, would give us 0. And the answer is x equals 1. So x equals 1 is another solution of 0. So it's the second solution. And then I go back further and I realize, well, wait a minute. If I start here, again, this is a horrible graph. I'm embarrassed. If I start here and I go left to right, and again, I know from here is 0. So from here to here, these two are again equal. If you look at the actual graph, you can see that they're equal. Okay, this is the better graph, but in this case they're equal, right? So therefore, this is also a starting point that will give us 0. So -1 is another starting point that will give us 0. So those are our 3 values. And there's nothing over here farther left that gives it. We go to the -4 and so on and so forth. So our final answer is where x equals 3, where x equals 1, and where x equals -1, the value r of x will equal 0. Okay, let me pause and shift gears. Okay, here's problem number 2. All right, this, as I said before, might be an 8-coin problem. Like I said, that was just a guess. But what we notice about this problem, and this is almost definitely going to have some sort of accumulation problem here, is I'm moving something is increasing and something's decreasing. So they're giving us 2 rates of change. Okay, that's an accumulation problem, and that means we're going to be using integrals. Okay, and as I said to you in the test, this is a definite calculator problem, but obviously they can make a problem where it's not a calculator problem. It's the same exact process, just in one you're using a calculator and one you're not. Okay. So part A, how much sand will the tide remove from the beach during this 6-hour period? Well, this is my removal function. Therefore, I simply do 0 to 6, and it says 6-hour period of r of t dt. We could put the actual function in here. We don't have to, especially because we're just really looking for the answer. So what we would do is we'd put this function in our calculator, and this one, by the way, but we'd start with this one, and we'd evaluate and integrate it from 0 to 6. And we get 31.815. They also have 31.816 cubic yards, which is a rounding issue, or not a rounding issue, but sometimes they accept both. So be careful if you're rounding, but just know that that's sometimes the situation. All right. B. I think what it means, I could round up if I wanted to, but I don't have to. Okay, I wanted to clarify. So this is the actual value you find in your calculator, which means you can round if you want. So they'll accept 1.816, but you do not have to round. Okay, but if your numbers are accurate through decimal places, you're fine. Okay. All right, moving on. So part B. The question is, write an expression for y of t for the total number of cubic yards of sand of beach. Well, for that total number of cubic yards, I need to be talking about my starting amount. So that's my initial. That's essential that I'm recognizing that. And I'm adding the rate of change difference. Well, this is sand in, so S is sand in, and I'm taking away sand out. When it says sand out, does not mean that's a negative value. So I need to subtract it accordingly. And there is and I have this is my t, and these are both functions of x. And that's that. Okay? All right. Part C. Rate of change. Okay, so part C says find the rate at which the total amount of sand on the beach is changing at t equals 4. Well, rate of change means derivative. So we have the total amount of sand on the beach. How much is that changing? By the derivative. Well, the derivative of this becomes 0, and the derivative of this integral, remember that's the fundamental theorem of calculus, becomes these two functions evaluated at t. So any derivative of an integral, we're simply evaluating these two functions at t. Therefore, my derivative is equal to, remember we talked about the 0, s of t minus r of t. And that is the fundamental theorem of calculus. There's 2 parts to it, but that's the A part. Don't worry about first or second. Okay? Then it says at time t equals 4. Well, all I do is evaluate it at t equals 4. And I do this right in my calculator. I do s of 4 minus r of 4, and I get negative 1.908. Again, this is a number where you can round up if you want. Cubic yards per hour. You have to put that in there. Don't get dinged for a point there. That's too bad. And any time we're dealing with rate of change, it's going to be per time. Okay, so anytime you say how much is something changing, it's going to be changing at such and such per time, in this case per hours. Okay.